ازيكم يا شباب، هنشتغل lesson 2 geometry. Vectors. What is the position vector? To summarize the position vector, it is a vector which its starting point is the origin point and its ending point is a point having x and y as a coordinates. OA here equals x and y, the coordinates of the point A, and its starting point is the origin point, and is denoted by the directed line segments OA, and you can express also A only without O. The position vector of a given point with respect to the origin point is the directed line segment OA, which its starting point is the origin and given by the point A, which is the ending point. Look at the opposite figure. OA is the position vector of the point A with respect to the origin point. So it is written as OA equals 3 and 2. And OB also is the position vector P, which its coordinates is negative 3 and 4. So we can denote it by OP equals negative 3 and 4. All position vectors having the same starting point. يعني ايه position vector؟ يعني بيبدأ من الأوريجين. Denoted by the position vector OA or by the symbol A only. By the same way, we can express P equals negative 3 and 4 also. How can we calculate the norm? To calculate the norm of the point A or the position vector A, which is x and y, its law is OA equals root x power 2 plus y power 2. A, the norm of the position vector A equals x squared plus y squared under the root. For example, if A equals 3 and negative 4 and we want to calculate the norm of A equals root x power 2, which is 3 power 2 plus negative 4 power 2, which is y power 2 equals 5 length units. By the same way, P equals negative 3 and 3 root 3. Then to calculate the norm of P, it equals x squared plus y squared negative 3 power 2 plus 3 root 3 power 2 under the root equals 6 length units. What is the unit vector? Unit means 1. So the vector whose norm equals 1 is the vector. For example, if A is a position vector equals 3 over 5 and 4 over 5 is a unit vector Y. To calculate its norm, you will square x and square y, 3 over 5 power 2 plus 4 over 5 power 2 under the root equals 1 length unit. So A here is a unit vector. What about zero vector? Zero vectors means its point or coordinates of x and y are zeros. To calculate the polar form of the position vector, OA equals a coordinates of x and y, and in x the norm of OA, and in y the inclination angle with x-axis, which is theta. Let's take example. If OA makes an angle of measure 30 degrees with the positive direction of x-axis, and its norm equals 6 length units, then OA in the polar form equals a coordinates x and y. In x its norm, which is 6, and in y the angle, which is 30 degrees. We can express it by 6 and pi over 6. So the polar form is a coordinates. Its x point is the norm and y point is the angle. X equals, to calculate x, OA, which is the norm, cosine theta, which is the angle, and y equals OA, which is the norm, and times sine theta, which is sine the angle. And you can get tan theta to calculate the angle by y over x, the coordinates of the point. So the Cartesian form, خدت البولار form اللي هو النورم والثيتا. طب what about Cartesian form? Another point, its x coordinates is norm multiplying cosine, and its y coordinates the norm multiplying sine. Let's take example. If OA is the position vector of the point A with respect to the origin point, then find the coordinates of the point A in each of the following. Number 1, OA equals 10 root 3 and 60 degree. So 10 root 3 is the norm and 60 degree is the angle. So you are going to calculate x coordinates and y coordinates. X coordinates equal 10 root 3 cosine 60 and y coordinates is 10 root 3 sine 60. So it will be equals 5 root 3 and 15, and write them in a point of x coordinates and y coordinates 5 root 3 and 15. By the same way, OA equals 6 root 2 and 135 degree. So to get x equal 6 root 2 multiplying cosine 135 and y coordinates equal 6 root 2 multiplying sine 135, you will get negative 6 and 6. So point A will equals to negative 6 and 6 in a coordinates x and y. By the same way, OA equals 8 and 4 pi over 3. So we are going to calculate x coordinates by multiplying the norm, which is 8 pi cosine angle 4 pi over 3. And we are going to get y coordinates, which is 8 multiplying pi sine 4 pi over 3. We will get negative 4 and negative 4 over 3 and negative 4 root 3. So the point A will equals to negative 4 and negative 4 root 3. Let's take second example. If OA is the position vector of the point with respect to the origin also, then find the polar form. What is a polar form? Polar form is a point coordinates. Its x coordinates is the norm and y coordinates is the angle. To get the norm, you will take the square root x power 2, which is 4 power 2 plus 4 root 3 power 2 under the root. And to get y coordinates, which is the angle, you will use tan theta. Tan theta equals y over x, 4 root 3 over 4. Now we get 8 length units in the norm and tan theta equals root 3. So theta equals positive root 3. And the measure of acute angle whose tan is root 3 is shift tan root 3, which is 60 degree. So to write the polar form, write a coordinates. X coordinates is 8 and y coordinates is 60 degree. Number 2, OA equal 5 root 3 and negative 5. So we are going to calculate the norm, which is root x power 2 plus y power 2. And to calculate y coordinates, we will multiply tan theta, which is negative 5 over 5 root 3 y over x. We will get 10 length units is the norm and tan theta equals negative 1 over 3. Notice carefully an important note. Here x is positive and y is negative, so it is located in the fourth quadrant. ومن الترم الأول احنا اتفقنا لو عندك angle located in the fourth quadrant, its law is 360 minus the first positive directed angle. To calculate the first positive directed angle, you will search for shift tan 1 over root 3 only. You will get 30 degree. And 360 minus 30 degree will be 330 degree. So the polar form will be 10, which is the norm, and 330 degree, which is the angle. Solve this and show me at the class. Let's move to another rule. Equivalent vector. Every vector A can be expressed by infinite number of equivalent directed line segments, as we discussed. In the opposite figure, A equals 3 and 4 is the position vector of the point A. And BC equals DE. Why? Because they are moving in the same direction and having the same length. Because BC norm equal DE norm, which is the distance, which is 5 length units. We can notice that the vectors are related by ordered pair, x coordinates and y coordinates. To add any vectors algebraically, you have to know that if the vector A equals x1, y1 and B equals x2, y2, and when you are asking about vector A plus vector P, you will calculate x coordinates together, x1 plus x2 in x coordinates, and you will calculate y coordinates, y1 plus y2 in the y coordinates. For example, if a equals 3 and 5 and b equals 2 and 1, if you want to get a plus b, add x coordinates plus x coordinates. 3 plus 2 equals 5 in x coordinates, and 5 plus 1, which is y coordinates, will be written at y coordinates like this, 5 and 6. Properties of addition. Closure property: a plus b when a belonging lil r and b belonging lil r, so a plus b belonging lil r. Commutative property: a plus b equals b plus a. Associative property: a plus b plus c in the brackets b plus c equal the same a plus b, then add c. All r equals to a plus b plus c. What is the identity element? If you add the identity element, which is the vector 0 and 0, you will get the same result. A plus O equals O plus A equals A. And O here is the position vector 0 and 0. Additive inverse property. For every ax and y, a plus O equals O plus A equals A, as we discussed. Negative A equals negative x and negative y. Negative here is negative 1. Multiply by each element x and y. And when you add a plus negative a, you will get 0 vector. So negative a is called the additive inverse of a. What is the elimination property? If you have a plus b equals a plus c, eliminate a from the right hand side and a was from the left hand side, you will get b equals c. What about multiplying by a vector? Multiplying a vector by a real number. If a equals x and y, and you want to multiply k by a, so you will multiply k with x and k with y. So it will be equals kx and ky. For example, if a2 and negative 5 and you want to get 3a, so 3 multiplying 2 will be 6, and 3 multiplying negative 5 in y coordinates will be negative 15 in y coordinates also. Distributive property. As we discussed, k multiplying a and k multiplying b, and a, b are vectors. Associative property. When you are multiplying k1, k2 by a, it will be equals k multiplying k2a. And elimination property, as we discussed, if ka multiplying a vector equals k multiplying b vectors, eliminate k with k, it will equals a 3. Let's take example 3. If a3 negative 1, b2 and 5, c negative 4 or 2, find each of the following vectors. 2a minus 3b. 2a means multiplying 2 by a. 2 multiplying 3, 6, and 2 multiplying negative 1, which is negative 2. So 2a is 6 and negative 2. And minus 3b. 3 multiplying p, which is 2, 5. 3 multiplying 2, 6. 3 multiplying 5, 15. So it will be equals 6 negative 2 plus negative 6 and negative 15, which is negative 3, equals 0 and negative 17. To get half 4a plus 2p minus c, first you will multiply 4 by a, which is 3 negative 1, and multiply 2 with b, 2 and 5, and subtract c, and the final result multiplying by half. So it will be equals to 10 and 2. Now 2o minus 3c plus a, where o is the 0 vector. So multiplying 2 by 0 vector will also be 0 and 0. And multiplying negative 3 by c plus a, first you will add c plus a, negative 4 plus 3, negative 1, 2 plus negative 1, which is 1. And multiplying the result by 3, you will get, yes, as you see, 3 and negative 3. Example 4. A 61, B 102. Find the norm of A minus 2B. So first you will get A minus 2B. Then second you will find the norm by root x squared plus y squared, the coordinates of the required point. A minus 2b is equals to 4 and negative 3 as we discussed. To calculate its norm, 4 power 2 plus negative 3 power 2 will be 25 under the root, so it will be equals 5 length units. 5 length units. Solve this and show me at the class. When you have equality between two vectors, so x coordinates in A equals x coordinates in B when A equals B, and y coordinates in A equals y coordinates in B when A equals B. If A 2 negative 3, B 3 and 5, express C, which is 12 and 1 in terms of A and P. So you will put C equals KA and LP. And now you are searching to find K and L. How? C equals KA plus LB. So you will multiply K by A, which is 2 and negative 3, and L multiplying B, which is 3 and 5. You will get 2K minus 3K plus 3L and 5L, which is equals to x coordinates plus x coordinates. You will get 2K plus 3L, and y coordinates plus y coordinates. You will get negative K plus 5L. Now 2K plus 3L and negative K plus 5L equals C, which is 12 and 1. By equality, you will get 2K plus 3L equals 12, x coordinates equality, and negative K plus 5L equals 1, which is y coordinates equality. So you will multiply by 3 this equation to get 6K plus 9L equals 36, and negative 3K plus 5L equals 1 multiplied by 2y to get negative 6K plus 10L equals 2. Now if I add 1 and 2, 6K will eliminate with negative 6K. So you will get 19, 9 plus 10, 19L equals 36 plus 2, which is 38. Dividing both sides by 19, you will get L equals 2. And substitute in any equation you want. I will substitute in 1. So I will get K equal 3. So C equals Ka, which is 3a, plus Lb, which is 2p. Important example. The fundamental unit vector. To summarize, the fundamental unit vector I, 1 and 0 is the position vector of the point 1, 0. Its norm is unity, and its direction is the positive direction of x-axis. And J, 0, 1, the position vector of 0 and 1, and norm is unity also, but its direction in the positive direction of y-axis, J in y-axis. So norm I equal norm J equals 1. To express the vector in the terms of fundamental unit vector, if you have the point A, X and Y, so you can write it A equals xi plus yj. To summarize it, xi plus yj. Like example, if A equals 2 and 3, you want the fundamental unit vector, so multiply 2 by I, and don't forget the arrow, plus 3 by j, and don't forget the arrow. Also P, negative 5i plus 1j, so you will write j also. Example 6. Express each of the following vectors in terms of fundamental unit vector. If A equals negative 8 and 6, you can express it by A equals negative 8i plus 6j. No I here because 0 multiplying I will vanish. So it remains negative 2j, and M equals 3 over 2i without j, and C will be equals to 2i minus 6j. To get its norm, as we discussed, to get its norm, so it will be equals to x coordinates power 2 plus y coordinates power 2 under the root. So norm A equals 10, norm L equals 2, norm M equals 3 over 2, norm C, which is 2 power 2 plus negative 6 power 2 under the root equals 2 root 10 length units. Easy one. Solve this and show me at the class. Let's move to example 7. Write each of the following vectors in its polar and Cartesian form, then express it in the fundamental unit vector. يعني انت مطلوب منك polar و Cartesian form و fundamental unit vector. You have a force of magnitude 12 Newton. Act in the direction of northeast. Northeast means, yes, like east and north. So the angle will be equals to, yes, 90 over 2. Why? Because northeast is the inclination angle with x-axis between the north and the east. So let the vector A, so the direction will be at 45 degree inclination with x-axis. So the polar form will be equals to 12 and 45 degree. 12 in the x coordinates and 45 degree in the y coordinates. Now we want to get the Cartesian form. Cartesian form means x coordinates, which is 12 multiplying cosine 45, and y coordinates, which is 12 multiplying sine 45 degree. So it equals to 6 root 2 and 6 root 2. A uniform speed of car covers 8 meters per second in the direction of north of west. To get the angle after west, stop at it, west, like this, the negative part of x-axis, and go to north by inclination 30 degree. When you find 30 degree inclination with the negative part of x-axis, you will calculate the angle with the positive part of x-axis. So you will find 90 degree plus the rest of 90 minus 30, which is 60. So the angle will equals to 150. By the same way, here I recommended 8 as the norm, and the angle will be 150. Now the displacement of body 24 meters in the north direction. North direction means the angle is in north, means the x part to north equals 90 degree. So the angle equals 90 degree. Number 4, a force of magnitude 4 kilogram weight in direction 30 degree east of south. After off is south. So you will go to east by 30 degree, and south stops at 270 degree. Plus 30 you will get, yes, 300 degree. Let's see the answer. Theta 2 will be equals 150 as we discussed. So the polar form is 8 the norm and 150 degree the angle. The Cartesian form multiply 8 by cosine 150, you will get negative 4 root 3, and multiply 8 by sine the angle, you will get y coordinates, which is 4. So finally the fundamental unit vector equals negative 4 root 3 I plus 4 multiplying j. Number 3, let the position vector C, and we discussed theta equal 90 degree. So the polar form will be equals to 24 and 90 degree. The Cartesian form equals 24 cosine angle, and the y coordinates equals 24 sine the angle. So it will be equals 24 at y coordinates and 0 in x coordinates. To get the fundamental unit vector, 0 multiplying I is 0 and 24 multiplying j is the y coordinates. Number 4, let the position vector the force D, so theta equals 300 as we discussed. The polar form equals 4 and the angle 300 degree, so the coordinates will be 4 and 300. To get the Cartesian form, multiply the norm by cosine 300 to get x coordinates in the Cartesian form, and to get y coordinates multiply 4 by sine 300. So it will be 2 and negative 2 root 3. To get the fundamental unit vector, multiply 2 by I plus negative 2 root 3j. Solve this example and show me in the class. Very important note. If A as a norm vector parallel to B as a norm vector, so its slope equals to the slope of B. So tan theta 1 equals tan theta 2. So y1 over x1, which is the slope of theta 1, and y2 over x2, which is the slope of the second line. And by crisscross, you will get x1 multiplying y2 minus x2 multiplying y1 equals 0. When you find x1 y2 minus x2 y1 equals 0, so the lines are parallel. And if the line's unit vector is perpendicular, so tan theta 1 times tan theta 2 equals negative 1, as you take at middle 3. So y1 over x1 multiplying y2 over x2 equals negative 1. And by applying multiplication y1 y2 over x1 x2 equals negative 1, by applying crisscross you will get x1 x2 plus y1 y2 equals 0. So when you find multiplying the x coordinates of 2 points plus y coordinates multiplying of the second points equals 0, so they are perpendicular. Let's take example to understand this point. If A 3, 4, B 8 and negative 6 and C 9 and 12, you want to check A perpendicular to B. So you will multiply x1. Now you will multiply x1 by x2 plus multiply y1 by y2. You will get this sum equals 0. And you want to check that A parallel C. Why? What will we do? We multiply x1 by y2 minus x2 by y1 equals 0. Note, the slope of A, to get the slope, divided y by x. Slope of A equals 4 over 3. And the slope of B, negative 6 over 8, which is negative 3 over 4. And the slope of C is 12 over 9, which is 4 over 3. You will find that the slope of A equals the slope of C, so they are parallel. And the slope of A multiplying the slope of B equals negative 1, so they are perpendicular. Let's take example. If A and P negative 2, 3, or negative 4, or M, find the value of M in each of the following. First case, A parallel P. When you have two parallel vectors, so you will multiply x1 by y2 minus x2 by y1 equals 0. So negative 2m minus 3 multiplying negative 4 equals 0. So 2m will be 12. So by dividing both sides by 2, you will get m equals 6. And when you find A perpendicular to B, so you will multiply x1 x2 plus y1 y2 equals 0. Now multiply negative 2 by negative 4, you will get 8 plus 3 multiplying m, which is 3m equals 0. Convert 8 to the right hand side by negative sign. You will get 3m equals negative 8. So divided both sides by 3, you will get m equals negative 8 over 3. Important remark. If m and 2m are parallel and in the same direction, so k will be bigger than 0. And if you have m and negative half m are parallel and on opposite direction, so k, which is the coefficient of m, is less than 0. As here, when k bigger than 0, so they are in the same direction. When you find k less than 0, so they are in the opposite direction. Let's take example 10. Represent the vector m 1, 2 as here, 1 and 2. Then draw point P negative 4 and negative 3, and C 2, 0, and D negative 1, 1, the directed line segment, which are equivalent to 3m, negative 3 over 2m, and negative m, easily. You have m1 and 2 starting from the point 0, like here. So it moved one part to x-axis and 2 parts at y-axis. To get 3m, so you will multiply 3 by m, which is 1 and 2. You will get 3 and 6. So you will move 3 parts at x-axis and 6 parts at y-axis. Starting from P, you will get 3 parts x-axis and 6 parts at y-axis. You will find E. Now you want to get negative 3 over 2m. Multiplying negative 3 over 2 by 1 and 2, you will get negative 3 over 2 and negative 3. So you will move from C starting point 2 and 0, negative 3 over 2 at x-axis part, and negative 3 at y part. You will get, yes, below, why below? Because negative parts. You will get n at, yes, negative half and negative 3. To represent the vector negative m, you will multiply negative by m, which is 1 and 2. You will get negative 1 and negative 2. So you will move from the point D, which is negative 1 and 1. Negative 1 means you will move to the negative part 1 place, and you will move 2 places at the negative part of y. You will get, yes, as here, L. Easy bar. Example 11. The opposite lattice represents the congruent parallelograms. Express each of the following directed line segment in terms of vector m and n. What is m? M is one place to the right hand side, as you see. And n, yes, upward one place. What about negative m? Negative m means opposite direction of m, one place. Negative m to the left. And n is downward. Negative n is downward by one place. So AB, A to B, I will move to the right hand by 1, 2, 3, and 4. So it will equals 4m. CB, I will move downwards how many parts? 3. So it will be negative 3n. Why negative? Because it moves downward opposite to n. CE is negative m. PC is upward 3 places like n, so it equals 3n. 5. BA. PA, I will move from P to A to the opposite direction of M 4 parts, it equals negative 4m. And KC is upward 2 places, it equals 2n. DL is the negative part of M opposite direction by 3, it equals negative 3m. And 8. DE, downward 2 places opposite direction of n, it equals negative 2n. Finally LA, yes, LA downwards 5 places opposite to n, it will be equals negative 5n. Important remark. If A and P are non-zero vectors, where vector A equals KB and K is a constant number not equal to 0, then vector A parallel to vector P. For example, if vector A equals 3 and 2 and vector B equals 15 and 10, can I take a common factor from this vector? Yes, I can take 3. As you see, vector B will equals 2. If you take 5 as a common factor, 15 divided 5 you will get 3, as we say. And 10 divided by 5 you will get 2. So vector B can be expressed at 5 multiplying 3 and 2. And from that I see 3 and 2 is vector A. So I can write it P equals 5 vector A. So directly, yes, vector B will be parallel to vector A. Why? Because vector P equals 5, which is a constant number multiplying by vector A. Solve this and show me in the class. Important problem. Important problem. Solve it and show me in the class. كده يا شباب نكون خلصنا lesson 2 geometry. اتمنى تكونوا فهمتوا، واللي يقف معاه اي حاجه يقدر يرجع في المدرسه. السلام عليكم.